We're carrying on with lesson 5, 1.5, input and output. In this section, we extend the set of simple abstractions, i.e. command line input and send output, that we've been using as an interface between our programs and the outside world to include standard input, standard draw, and standard audio. Standard input makes it convenient for us to compose programs and process arbitrary amounts of input and to interact with our programs. Standard draw makes it possible for us to work with graphics and standard audio sounds. So let's have a bird's eye view. The Python programs that we've seen so far take input values from the command line and write a string of characters as output. By default, both command line input and output written by the programs are associated with the application running on your computer that accepts commands, that is, application in which you have been typing Python commands. We use generic terminal window to refer to the application. So far, the Python programs that we've used have been the command line input. Any Python program access an array of strings referenced by sys.argv. And that array contains a sequence of command line arguments that we type provided to Python by this operation system. By convention, both Python and the operation system process arguments as strings. So if we intend for a command line argument to be a number, we use conversion function like as int or a float to convert it from a string to the appropriate type. Standard output. To write output values, we have been using the function standard io.write and standard io.write line. When a program calls those functions, Python puts results in the form of an abstract stream of characters known as standard output. By default, the operating system connects standard output to the terminal window. All of the output in our program so far has appeared in the terminal window. The program random_sec.py uses it takes an integer command line argument n and writes to standard output a sequence of n random numbers between 0 and 1, possibly including 0. To complete our program model, we add the following. Standard input. So let's first have a look at random_sec, which is over here. So it accepts an integer, standard libraries, accept integer command line argument n, and write to standard output a random sequence of n floats in the range of 0 to 1. So we get an input in, and we write a pretty standard for loop from I in range n, and write that. So standard input, the book site standard io.py module defines several functions in addition to write and write len. Those additional functions implement standard input abstraction to complete the standard output abstraction. That is, standard IO module contains functions that allows your programs to read from standard input. Just as a program can write to standard output at any time, a program can read from standard input at any time. Standard draw, the book size standard draw module allows your programs to create and write drawings. It implements a simple graphics model that allows your program to create and write points, lines, and geometric shapes, the window on your computer. Standard draw also implements features for animation. Standard audio, the book site standard audio module allows your programs to create and play sound. It uses standard format to convert arrays of floats into sound. Standard output. This is an API of the part of standard IO by the Py module that is relevant to standard output. Standard write.x, standard write line, and standard write f, which we have used before, but effectively it writes the arguments arg1 to standard output as specified by the format string fmt. Standard write line and standard write functions are the ones you've been using so far. Standard write f function gives you more control over the appearance of the output and deserves some explanation. Formatting, writing basics. Simplest kind of call of standard write f passes only one argument. That argument should be a string. In that case, standard io.write f simply writes a string to standard output, and so is equivalent to standard write. More common call of standard write f passes two arguments. In that context, the first argument is called the format string. It contains a conversion specification that describes how the second argument is to be converted into a string for output. Conversion specification has a form of %w.pc, where w is the field width. The field width is the number of characters that should be written, and negative field width indicates the output should be padded with spaces on the right. P is the precision for floats. Precision is the number of digits that should be written after the decimal point. For strings, the precision is the number of characters of the string that should be written. C is a conversion code. The conversion code should be D when written for integer, F or E for float, and E and S when a string. So here's a bit of A drawing showing in detail using write F percent. For example, the field width %7, precision point F. F is a conversion code. So here's some examples for sample strings. Sample width 14D minus 14D, and converted to the string format. For float, you have these conversion strings and these ones as well. So standard write F function can take more than 2 arguments. In the case, the format string will have a format specified for each argument, perhaps separated by other characters to pass through to the output. Any part of the format string that is not a conversion specification is simply passed through to the output. For example, the statement is the following. Standard write F pi is approximately the following percent dot pi F. So let's copy this and see what we get. Let's get that, copy it and enter. And we say, well, it's missing standard IO. So let us now input standard IO. Input standard IO. And we need a math library. So let's say import math. And then we get the correct format, which is pi is approximately 3.14. It is to 2 decimal places specified by the point to F. And F would be referring to the floating point number we expect. So multiple arguments. Standard write F function can take more than 2 arguments. In this case, a format string will have a conversion specification for each argument, perhaps separated by other characters to pass through the output. Formatted string, formatted writing implementation. Internally, the standard write F function uses the percent operator, specifically a function call of the form standard write F format string and value. Internally is implemented using an expression of the form format string percent value. As you know, percent operator is an expression of the form integer. Percent integer means the computer, i.e., compute the remainder or the modulus. A modulus operator is an expression of the form format string modulus value, which means to convert the value to a string as directed by format string. The Python documentation for string formatting operations can be found here in this link. And this describes the modulus operator thoroughly. Thereby, indirectly, it describes standard IO.writeF function thoroughly as well. Standard input. Our standard IO.py module supports standard input, an abstract data stream that may be empty or can contain a sequence of values separated by whitespace. Each value is a string or value of one of Python's primitive types. One of the key features of the standard input stream is that your program consumes values when it reads them. Once your program has read a value, it cannot back up and read it again. This is a part of the standard IO module that is relevant to standard input. And there are many examples to check if something is empty. Is standard input empty? To read a token, convert it to integer, convert it to float, convert to Boolean, read a token, and return a string. Check if it has a next line, read the next line, return a string, read all remaining input, read all inputs, read floats. So many examples. These functions fall into one of 3 categories. Those for individual tokens, one at a time, and converting each to an integer, float, Boolean, or string. Those for reading lines from a standard input, one at a time, and those for reading a sequence of values of the same type, turning the values in an array. Generally, it is best not to mix functions from different categories in the same program. We now consider a few example programs that illustrate how to use standard input. Typing input. The program addInts is found here. Accepts a command line argument n, then reads n numbers from standard input, computes the sum, and writes the sum to standard output. Let's have a quick look. Pretty straightforward to work out the sum of the values by using specifically the readInt function, which is fairly new. We haven't used it before. It read an int. So when you use a Python command to use a Python program from command line, you actually are doing 3 things. Issuing a command to start executing your program, specifying the values of the command line arguments, and 3, beginning to define the standard input stream. The string of characters that you type in a terminal window of the command line is a standard input stream. When you type a characters, you're interacting with your program. The program waits for you to create the standard input stream. When you type Python add-ins after accepting the command line argument, the program calls send io.readInt and waits for you to type an integer. Suppose that you want 144 to be the first input. As you type 1, and 4, and then 4. Nothing happens because standard IO does not know that you are doing that you're done typing integer. But when you then type return or enter to signify the end of your integer, standard io.readInt immediately returns the value 144. After you've typed 4 numbers in this way, the program expects no more input and then writes the sum to standard input as designed. So let's have a look at this code. Let's create a new Python file called addins.py. This is not correct. Go addins.py, paste the code. See what it does. So it will read int until the number n is satisfied. So let's run that. So %run add ints. I need. What is it complaining? Oh, I need to specify number, for example, 4. Oh, I think there's an issue here because this program, Jupyter Lab does not accept inputs in this way. So let's make it in 4. And this, if you're running VS Code, this would work. Just get these libraries. Yeah, so Jupyter Lab kind of limits how inputs are interpreted. So we have to do it in the cell itself. Read line. So I think there's a problem again with standard io.readInt. Anyways, this probably might work in VS Code. We can try again a bit later. So if you type ABC 12.2 or true when standard readInt is expecting an integer and then it responds a value error. So let's check how that works. All right, so I decided to rather show you how this works in Visual Studio Code because a lot of this example discusses it. So open Visual Studio Code, copied it over here as a file, and for example, if I run the file, say 4, and then it expects 4 inputs to sum. So I can say 1, 2, 3, 4, and then it adds the numbers up, and it gives you 10. So if you type ABC or 12.2 or true, it gives you a value error. So let's try that out. Let's see, like ABC can give an error because invalid literal, it is expecting int only. So format for each type is the same as you have been using for literal values within programs. Standard IO treats strings of consecutive white space characters as identical to one space and allows you to delimit your numbers with such strings. Doesn't matter how many spaces you put between them, whether you enter numbers on one line or separate them with tab characters or spread them out several lines, except that your terminal application process standard input one line at a time. So it will wait until you type return before sending all of the numbers on that line to standard input. You can mix values of different types in the input stream, but each time that the program expects a value of a particular type, there needs to be a value of the type in the input stream. Interactive user input. The program 20 questions, let's have a look. It is here already.